Hello everyone, Jimmy here. This is Monday, August 5th, 2019, and I'm doing now my third stream of the last week or so. I'm going to be working on developing Ruma, which is a Rust implementation of the Matrix protocol. In the last stream, before I get started on any Ruma specific stuff, I wanted to show off this really cool website that was linked on Hacker News yesterday, called cheats.rs, and it's just a cheat sheet for Rust that shows a whole bunch of very succinct examples of how you do various different things. So mostly it's like syntax related, but some of it is a little more conceptual. So here, for example, here's the syntax for various types of data structures and the forms they can take, how you actually initialize those structures, different types of references, what all the different function syntax means, control flow operators, module system. It's really pretty comprehensive. I think it is kind of a good guide to sit beside like the Rust reference or the Rust book as you're learning. If you just want to look at like, okay, I found some kind of weird syntax and I'm not sure what it means, it might be easier to find an example of that and its definition on this than it would be through looking through the reference or something where you have to kind of have a better idea already of what you're looking for. So let me start up a file for the show notes for this episode, and I'm going to put this in here because it is pretty cool. Whoops. Oh, cheatsheets.rs. So yeah, very cool. Check it out. All right. Let me load up Twitch here. Also another thing new from last time is we had discussed how there were a lot of questions that were going to be kind of repeated from time to time on the stream, where people are going to continually ask what Ruma is and basic questions about Matrix and Rust. So I did a little bit of searching for what people are using for bots for Twitch chat, and there seems to be the most popular one is this bot called MooBot. Let's see, MooBot, Twitch MooBot, moo.bot, this thing. So I signed up for this thing, and we've got one of those running in the channel now. So if anyone is asking basic questions like what is Ruma, what is Matrix, blah, 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 you can just type in the chat, !FAQ, hit return, and MooBot will send you a link to a blog post that I made, which has those basic answers. Basically, it's the same thing that you see right here on the Ruma homepage that answers these three questions, but over time, as the frequently asked questions specific to my stream get change or develop or whatever, I'll be able to update that post to make sure it has the same stuff. So that's a good start in kind of reducing the amount of churn there. Okay, so on the last stream we worked on Ruma API, this library, and we merged the Ruma API macros library, which was previously this separate repository, into a subdirectory, and merged these two so that the procedural macro that is defined in Ruma API macros is re-exported by Ruma API. So now there's been new releases of all of these. So you can see here's the latest ones. Ruma API macros 070 is the one that we worked on together on the last stream. And then back here somewhere is the latest version of Ruma API. Yep, 010 is the one that has the changes that we made in the last stream. And the former Ruma API macros repository is now read-only archived because we no longer need this. So I moved all the issues over, and we can pretty much ignore this from now on. It'll all be under this repository. So this work was part of the sort of long haul to update all of the Ruma libraries to be compatible with the current version of the Matrix specification, which is R050. Let's see, which is this guy. Client server spec R050. That is what we want. And And so the next thing to do, actually, I guess it would help to also, let's look at the projects. So here on the Ruma website, we have this projects page that shows all of the different libraries that make up the Ruma project. So you can see here Ruma API and API macros, which we were working on last time. We're kind of working up to Ruma client. This is like the high-level API client that you would use as a developer to write some software that integrates with a Matrix home server. So Ruma client depends on Ruma API and API macros, and it's sort of like a next level dependency is Ruma client API. This is where all of the request and response types for each API endpoint are defined. And that in turn is built on Ruma API. So that's why we were starting at kind of the lowest level. The other sort of major components are ruma-events, which is where all of the event data structures are defined. And if you're not already familiar, an event in Matrix is sort of like the core data type that all of the messages that happen in the system are represented as. So sending a message in a chat, joining a room, leaving a room, inviting someone, changing the topic of a room, changing the alias or the name of a room, like all that stuff is represented as an event. So this is where the sort of declarative definitions of these events are defined for Ruma. And then these last two down here are Ruma identifiers and Ruma signatures are also sort of components for doing other sort of subsections of what Matrix does. So Ruma identifiers is just types that represent like a user ID or a room ID and things like that, and logic related to them. And finally, Ruma signatures is the library that handles digital signatures, so signing JSON, signing events, and making sure that you can verify the provenance of an event and know that it came from a particular home server whose public keys you have access to. So Jonas Platt is on the stream today, or at least he's in the chat saying hello. He's the sort of other member of the Ruma organization on GitHub and does a lot of work on the client-side libraries. He's also been streaming, or started streaming as of yesterday, I think, or the day before. So I'll put a link to his stream also in the show notes for anyone that wants to check him out. That's twitch.tv/jplatt. So we'll do, okay. So what we're going to work on in this episode is Ruma events. This is a library that has been seeing some pretty major revisions over the past month or so. One of the main problems that we had, and I'll show you, let's try to find let's go to docs.rs and look at Ruma client API, see if I can find a good example of an endpoint where this is I guess sync is probably the most canonical one. So the sync endpoint in the client server API is sort of the main event loop that a client will use. It does a long pull to this sync endpoint, and the sync endpoint will send to the client all of the new events that have been created on the home server since the last time the sync happened. So basically the client just sits in a loop requesting this sync endpoint and deals with new events as it receives them. And this pretty directly shows the problem with what the previous Ruma events app had. And actually, I should probably show you the previous Ruma events so we get an idea of what I'm talking about here. So let's look at, I think version 012 maybe will have what I'm talking about. So let's get an example of an event. So we have, let's say a room. Let's look at like, I don't know, a alias event. So here's an example of a specific event that's defined in Ruma events. We have a thing called aliases event, which is just a struct that looks like this, and it's got this is sort of representing a JSON structure from the matrix spec. In fact, we can go look at m.aliases. So here's an example. Here's the m.room.aliases event as defined by the matrix spec. You can see that this JSON structure here is an example of this structure here. So that's pretty much what Ruma events is. It's just definitions of all of these matrix event types. And importantly, all of the event types in Ruma events implement these two traits, serialize and deserialize, that come from serde, the serialization library for Rust, which is serde.rs. This is pretty much universally used across the Rust ecosystem as the go-to library for handling serialization and deserialization. And in particular, in Ruma, we're concerned with JSON serialization and deserialization, because that is the format that Matrix uses for all of its data interchange. So this has worked out fine. You can, if a type has these traits implemented, serialize and deserialize, then they can also appear as sort of components of larger structures that also implement those traits. So if we go back to Ruma API, or sorry, Ruma Client API, where this sync endpoint is defined, we can find, let's see, where's the request and response? Sync events, request. I guess request is not really what we want. So let's look at the response of this event. And let's also go back to the client server, and we'll look at sync, so we can kind of see, here's the specification, the way it defines the response format from the sync endpoint is right here. So it's kind of this very, very large structure with a bunch of nested stuff in it. But ultimately, if we go down to an example of it, we can see that there's these arrays of events. So here's an example of an m.room.member event. And so you can see this right here is just a matrix event, this particular object right here. That's an m.room.member event. And so this response will contain a bunch of these events like this. And because this structure implements serialize and deserialize, and so do all of its parent structures, we can have a big type like this response, which you can see mimics this structure. It has at the top level next batch, rooms, presents, blah, blah, blah. So this is basically just a Rust representation of this JSON structure. And if you take some input and you try to deserialize it as this type, it will go down through the nested levels of the structure, deserializing all of the components to create this sort of larger structure. One thing we wanted to do with Ruma events, however, is there's certain places in the spec where there are events that can have a bunch of fields, but not every possible combination of values for all of those fields would constitute a valid event. So we wanted to have some way of doing sort of like a logical validation of an event in addition to just sort of the direct deserialization from JSON. So we want to be able to say, yes, we know how to treat this JSON structure as a Rust type, but it has values in it that are not like semantically valid in terms of what the specification requires. And so what we tried to do in the last revision of Ruma events is separate validation of events from deserialization of events. And I thought I had come up with an API for that was going to work, but as it turns out, it had a pretty kind of significant problem that is preventing us from moving forward with it. So if I go and look at docs.rs/Ruma events, let's take a look at 0.14, which is the current release that has this sort of revised version. And let's go look at the same one that we were looking at before, which was room aliases. So if we look at alias event here in this latest version of it, you can see at the top level it looks pretty much the same. We've still got all the same stuff, more or less. But if we scroll down to the traits that are implemented, you will notice that deserialize is no longer listed as a trait that is implemented for this event type. And the reason for that is that if people were able to deserialize the structure directly, there wouldn't be a way to represent an invalid event. We would have to essentially bake that validation logic in with the deserialization step. And we wanted to treat deserialization as just kind of a straightforward translation between JSON and Rust structures. So what we have instead is an implementation of from string right here, and an implementation of try from. So these are actually exactly equivalent of each other. And what this allows you to do is take a string slice, which is like this type in Rust, and if that string contains JSON data, we can call parse on it, and via the from string implementation, this is a little, I guess I should go into this for a second. So from string is this trait in the standard library that if implemented for a type will allow you to call the string slice parse method. So you can see right here, they have this, the 0th index of chords is a string slice, and then calling parse on it, and specifying that you're trying to parse it to an I32 type. We'll use this from string implementation to try to convert from the string into a type of this value, or a value of this type. So we're using this API. This has been in the standard library since Rust 1.0. There's also a more recent API, which I talked about in a previous stream, called try from, which is, it's on this tab. Try from. So this is kind of a generalized form of this idea of converting from one type to another where the conversion might fail. And try from just lets you specify what the type you're converting from is, whereas from string is always converting from a string slice. So we implement both of them just for completeness' sake, but they do exactly the same thing, and one of them is implemented in terms of the other. But basically the idea here is exactly this. So, and I think if we go back to the top level, it describes this somewhere. Yeah, this section here says basically you got some JSON data, call parse on it, try to deserialize it to a type, and instead of just giving you a deserialization error, we now have the error type for that, because remember this can fail. So either you're going to get back an aliases event if this deserializes and validates correctly, or you're going to get this invalid event type. And what invalid event is a way to represent the original data that was received that may have deserialized correctly, but is not considered valid for some sort of semantic reason based on the rules of the spec. And so this error is going to include a message about why the event failed validation. And if deserialization succeeded but validation failed, it will also include a SERDY JSON value type, which is essentially just a totally direct translation from JSON data to a Rust type that represents that JSON data without any sort of application-specific meaning. So this is essentially the raw data that deserialized but failed to validate. And the reason that we want this whole crazy API is that if we go back to this example of this large sort of response structure that comes from the API, the way deserialize works is that if any of these sort of substructures fail to deserialize, then that will cause the entire aggregate structure to fail to deserialize. And so what was happening when you actually tried to work with Ruma client is that if for any reason we got data from the server that did not exactly match the structure that was expected by Ruma's libraries, the entire response would fail, and you would have no idea what part of it failed, and you would have no ability to sort of introspect the individual components of that. So essentially what we want to happen is, like, let's say that we receive something from the server that has like one of these fields is a different data type than what Ruma thinks it's supposed to be. What will have happened previously is that single type error on a single event will cause this entire structure to fail deserialization, and we'll just get this opaque error saying, sorry, you can't do anything with this. And as a result, the library is not really that useful, because when you're getting data from potentially unknown sources like home servers with different implementations, or just data that was considered valid in the past but under new rules has stricter validation, like, we need to be able to handle invalid data and inspect it. So if we have a list of events and like one of them is invalid but the other 5 are valid, we want to be able to keep the 5 valid events and keep the invalid event in sort of the same collection in a way that we can sort of introspect the original data and sort of pick out parts of it that we might need, and just kind of figure out what went wrong. So this is both important in terms of being able to develop Ruma, like we need it to be able to handle errors more gracefully, because like when we're working on this stuff and debugging it, we get these giant opaque failures and have no idea like what the specific problem was and how to deal with it, how to improve the Ruma representations of things so that things will not fail. And also just like even when we get the project implemented the way we want it, like it still needs to be able to handle unexpected data that will come from untrusted or buggy sources that will somehow get invalid data into the system. So the problem with this approach that we did in ruma-events 014 is that it essentially comes down to the way that deserialization works. Basically, all the places where in the API where we are referring to, let's see, go back to Ruma Client API. All the places where we're referring to an event like this. So let's actually dig down. We'll go into rooms, and then hash map of, let's say, joined room, where the timeline. So here we have a vec of room events, deeply nested inside of this structure. The problem is that the way that you actually deserialize this larger structure is just by calling deserialize on the top level thing, and then, as I said, the deserialize implementation will sort of delegate down the nesting of structures. And because what we want to do is we want to replace essentially this under the new API would be, instead of vec room event, it would sort of be a vec of results where each individual item in the vector will either be a successfully deserialized and validated event, or it'll be one of these sort of invalid event representations, so that we can have a vector, like I said, where you have, like, let's say 5 events that successfully deserialized and validated, and one that didn't, and we don't want to throw it all away. So basically, anytime an event appears in one of these structures, we want to replace that with a result of the event or an invalid event. And the problem with that is that the way you create those, it no longer exposes. I guess we can get rid of this now. It no longer exposes this deserialization interface. So when you're calling deserialize on this top level structure, there's nothing that deserialize can call to get this, because it doesn't have an implementation of deserialize. So when trying to use ruma-events 014 in Ruma Client API, like Jonas, who tried to do this and quickly discovered that like the two APIs just don't plug into each other properly. Like there's no way to integrate them. So we've been talking about how we're going to approach this, like how do we resolve this problem? And we're kind of going to have to go back, I think, a little bit more closely to the original design, in that there needs to be a top-level deserialize implementation. But what we're going to do differently this time is, rather than having the events themselves implement deserialize, we're going to implement deserialize only for essentially a result type. So you can deserialize a result of aliases event in the OK case and invalid error in the error case, but you can't deserialize an aliases event directly. We're going to still sort of hide that implementation inside the details of that result. And so this seems like it would be fairly straightforward, because you can just, implement deserialize for result. But the problem with that is that serde already provides a deserialize implementation for that. So if we go look inside serde at the deserialize trait, and then if we look for result, yeah, right here. So you can see serde already includes a blanket implementation. So any result type, the result from the standard library, any type that implements result where both the inner types are results, will get sort of triggered, but it will trigger this particular implementation. And so because of coherence rules, which is another sort of can of worms, we can't do an implementation of deserialize directly for this type inside Ruma events, because it would conflict with this implementation. And to explain that a little bit more, so there's this thing in Rust called the Coherence Rules, which are sort of a list of rules for how an implementation for a trait is selected. And the rule, generally speaking, is that if you have a type T and a trait, let's say TR, there has to be exactly one implementation that will be obviously chosen for which one to use when trying to call a trait method on that type. And so if you have two implementation blocks somewhere in your program that the compiler is unable to decide between when it gets a type that implements a trait, and let's say it finds two blocks that both potentially could apply to the particular case that you've run into, the compiler will fail to compile your program, and it'll say conflicting trait implementations. So this becomes a problem when you have something like this, where you have what's called a blanket implementation. It's essentially when you're implementing a trait for a generic type. So rather than saying like, we're not implementing deserialize for a result of aliases event and invalid event, where this is implementing it for all types in which these particular trait boundaries are upheld. And so if I try to implement deserialize for like my specific concrete types in this one specific case, Rust will see that there's these two conflicting implementations, and it won't know which one to choose, and hence we essentially can't write that implementation. So I think the best and possibly only way we can get around this is by creating what's called a new type, where you create sort of a structure type that internally holds a representation to this inner type that you care about, but is also a distinct type from sort of like the compiler's point of view. And in that case, we implement this deserialized trait for our own type, and then internally in that implementation, we sort of pull out the inner result and work with that, so that it kind of adds this layer of indirection, which is not an ideal use from the sort of library user's perspective, but it gets around this coherence rule of this requirement of having to have at most, there has to be one and only one implementation of a trait for a given type that the compiler needs to know how to pick. And now that I'm actually looking at this blanket definition, I noticed that this actually says that result of T and E is only implemented here if T and E are both deserialized individually. And I'm now wondering if we might actually be able to get around this, because in our example, remember the whole point of this is that we don't want people to be able to deserialize the event directly. They can only deserialize a result of the event or an invalid event. So I wonder if it would actually be possible to do this, given that the fact that T does not implement deserialize means that it wouldn't match this implementation. I have a feeling that the compiler's not going to be smart enough to distinguish that. And let's see. Oh, Jonas is saying the Orphan Rule would forbid us from implementing deserialize for result, even if there was no existing implementation in Serde. Yeah, that's true. So another part of Coherence Rules is this idea called Orphan Rules. And Orphan Rules says that if you're implementing a trait for a type, either the trait or the type that you're implementing it for must be defined in the current crate. So in this case, we actually couldn't do an implementation of result for deserialize inside Ruma, because result comes from the standard library and deserialize comes from Serde, and neither of those is the same crate that we're writing the implementation in. So for that reason, Jonas now reminds me exactly what I was just saying, that maybe the compiler can figure out that because T is not deserialized, that it's a distinct implementation. That's not even, that won't even come up because we still can't write this implementation. The only reason Serde is able to do this is because it defines deserialize. So remember, the rule is that you either have to own the trait or you have to own the type when you're writing an implementation. And in this case, we will not own either of those, and so we have to do this via a new type. So, all that out of the way, that basically is the explanation for what we're going to be doing today. And I realized it took me like half an hour to even explain the problem. But I wanted to sort of give enough context about what's happening here that what I'm going to do on this stream makes any sort of sense. And so I've been thinking about this problem for a few days just in my head. I haven't played around with any of the code. So I don't know necessarily that this is going to work out exactly as I planned. I think it's probably pretty likely that we're going to run into some sort of problem that I didn't foresee. But that's why we're doing this, so that I can learn and you can learn and we can make progress on implementing Ruma. So let's start actually looking at some code now. Get rid of all this stuff that I was working on from before. And we'll open a new window. We're going to go to ruma-events. Let me open another tab, ruma-events. Okay, let me make sure I don't have anything in my working tree. I don't have any new changes to pull down. So yeah, let me close this stuff, and we're just going to look at... I guess we don't really need Ruma's website open right now. We may need this, but probably not. So I think what I'm going to do to start is I'm just going to run cargo doc open. And we're going to take a look at the local documentation, because I find this is always a way that helps me sort of visualize the layout of the types and everything in a crate. Just the sort of visualization of the layout of things I find to be helpful in getting my bearings and thinking about library design. So we'll give this a second to load everything and open up the docs. Also, another interesting thing about the implementation of ruma-events is that because there's so many events, and you don't want to have to write manual implementations for all of this, like from string, try from stuff. Like there's a lot of boilerplate that's associated with this pattern of having sort of like a deserialization and a validation step that are separated, and I'll show you why that's the case in a second. There's actually another crate called ruma-events macros, which has a procedural macro that will sort of allow you to sort of declaratively state the structure of an event, and it'll automatically generate all this stuff for you in the common case where there actually isn't any sort of extra validation we need to do. Because as it turns out, like most of the events don't need validation beyond their sort of deserialization implementations. Like essentially, as long as the types check of the individual fields, then it's fine to just deserialize them directly. There's only a few events that we decided we want to have stricter validation rules for, and I actually don't even remember what those are off the top of my head. So I think what we're going to do to find them is, let's see, I'm going to look for impl deserialize, I guess. Did I spell that wrong? Oh, no, it needs to be impl de, deserialize. Oh, God. Aha. So here are places where deserialization has been implemented manually. So the places where there are manual implementations are the ones that have extra validation, because the ones that use the macro are for the sort of boilerplate case where there is no difference between a deserialized event and a deserialized and validated event. So let's look at, let's see, which one of these do we want to look at? I think key verification start might be a good one. So let's look at source key verification start. And actually, let's look at it here, because I think it's a little easier to see. So the key namespace, verification namespace, these are events that are related to the end-to-end encryption API. So this event happens when two parties are trying to verify, or one party is trying to. I guess it's actually both. It goes both ways. This is for when you're exchanging encryption keys for an end-to-end encrypted chat session. You want to be able to verify out of band that the keys that you receive from the other person are in fact their actual keys, because if there was a malicious sort of user or client on the other side just sending you some bogus keys that didn't actually come from the real person that you thought you were talking to, you need some way to check outside of the current protocol implementation whether or not that person really sent those values to you. So the current version of Matrix includes like an interactive verification thing where it'll show you like a series of emojis, and you talk to like the series of emojis are like sort of generated from the contents of your public key, and then you are supposed to talk to the person who you're trying to verify via some other mechanism, like over the phone or another messaging software, and say, hey, it's displaying these 6 emoji to me. Is that the same 6 emoji that it's displaying to you? And if you both agree that it is, then you have now verified out of band that the person over Matrix is indeed who you think it is, and you can now sort of verify their public key and trust them. So this is this event called m.key.verification.start is essentially the Matrix event that signifies the beginning of one of those interactive verification sessions. And the reason that we are... well, let's just take a look at it. So we've got start event, and this begins an SAS key verification process. I forget what SAS stands for. Let's see if it shows. What is SAS? Short authentication string. So that's referring to like the emojis or something like that, where you just see like 5 emojis instead of having to like verify some really long encrypted hash. Okay, so this is what our start event looks like. It has only one field, which is start event content. And within the start event content, there is only one. It's actually an enum, and there's only one variant, which is the variant that uses the m.sas.v1 verification method. And so what we're looking at here, so if you look in under the device verification section in the spec, you'll notice that m.key.verification.start appears here, and it also appears down here, whereas generally there's only one definition of an event in the spec. The reason for this is that this top level one is sort of a generic structure that will be the case for any sort of interactive verification, regardless of what sort of algorithm or protocol it uses. So these are the fields that will, at least in theory, be in common to all forms of verification. And you can see that there's this method field, which is a string, and it's required, and it defines which particular verification method you're going to use. So the structure of this event is actually going to change based on the value of method. And as it turns out, if we go down to this bottom version of the definition of mkey verification start, this is the version of it where method is specified to be msas_v1, which is presently the only method that is actually defined in the specification. So the structure of the event is sort of defined in a way that can be abstracted over time, but there's actually only one valid representation of this event currently in the existing spec and in the wild. So what that means is that if you try to construct a verification event that uses something other than this known msas_v1 variant, it is technically conforming to the structure of the start event, but it's not actually valid because the system can't work with it. So this is an example of where deserialization of the JSON structure is not enough to verify the correctness of the contents of an event. And so we can't just deserialize anything here. It has to be one of these particular variants. So we only support this msas_v1 content variable. And similarly, the actual details of what's in this content event have very specific requirements. So you can see here we've got these 4 fields of the content object called key agreement protocols, hashes, message authentication codes, and short authentication string. And if we look down here, we can kind of see that in each of these, it's a list of identifiers that sort of tells the other side of the communication which of these sort of protocols it's going to be using, or like essentially the details of the algorithms that it's going to use for these various things. And then if we look also up here in the description for these fields, we can also see the fields are required. And for example, for key agreement protocols, it says the key agreement protocols the sending devices understand must include at least curve 25519. So what that means is that if we receive an event that has essentially this structure, but the key agreement protocols array does not include curve 25519, then it's actually not invalid. Like, it does not meet this requirement as specified by the spec, even though the JSON is valid. So this is exactly what I was talking about at the beginning of this stream, of like, we want to verify that this is actually in there in order to treat this as an acceptable event, even if we can deserialize it. So if we look at the way this works, and in fact, we can actually see it going the other way too, in that we want to make sure that someone who's constructing an MSAS v1 content event can't construct one that doesn't contain one of those valid representations, which is why this has its field it's omitted. Like, you can't publicly access the key agreement protocols vector that lives inside this content, because we need to uphold the invariant that it will always contain at least this curve 25519 variant, and so on. And so the way this works is that we just have a public constructor that takes options, and this options hash essentially is sort of like the equivalent of like what those public fields are, except that this will get validated. So like we were just talking about, here's the key agreement protocols, here's a vector of key agreement protocols, and you can see there's only one here. And so we have to verify that that's actually in there. So if you create one of these things and this doesn't have one of the values that's required, then rather than getting back a sort of an OK variant of this, you'll get an invalid input. And invalid input is basically the same thing as invalid event. It's like a validation error, except this is used during the construction of an event that you're creating in Rust, rather than a deserialization of JSON that came over the wire. But similarly, this has the same thing where you can... Oh, I guess you can actually deserialize this. That's interesting that that's exposed. I thought that was... We didn't want that to be exposed. I guess it doesn't matter because you're always working with this higher level thing. Yeah. So you can see on the actual start event content itself, we've got the try from string and from string implementations, but we don't have a deserialize implementation. And that's exactly why, because we want to be able to separate them, the validation from the deserialization. So let's take a look at how that actually is implemented here. So we've got start event content, and here's our from string implementation. And then the way that this separation works is that all of the events have a private module called raw, which is down here. And inside the raw module is essentially a copy of the exact same event, except it does implement deserialize. So you can see we've got the same... actually, I'll create this in 2 tabs so we can look at them simultaneously. So here on the right is the public start event content, which you can see has these 2 variants. One is just a non-exhaustive one that we're using to allow the enum to be extended in the future without making it a breaking change. But basically, we just have this one variant that uses an MSAS v1 content struct as its data. And then inside the raw module, we have exactly the same thing. We've got another enum with exactly the same name and exactly the same variants, and the variants have the same name. And the only difference here is that this start event content does implement deserialize, which we can see right here, whereas this one does not. It only implements from string. And so inside this from string definition, we have access to the raw version of the event because we're in the same REST module that has access to its child module, but the raw event is not visible outside of this parent module. So it's kind of just a private implementation detail. And so this is why I was talking about the ruma-events macros crate. Essentially what that does is, for all of the events in which there is no distinction between a deserialized event and a valid event, we don't have to want to write all of this extra like raw mod stuff, because it's literally exactly the same thing, and it's only there to support this API commonly across all of the events. So essentially all the stuff in this file is generated automatically by the macros. So let's see, let's look for Ruma event. I think we need no? I guess it needs to be, yeah, okay. So if we look at, for example, aliases, so all of this stuff in this case is Ruma event. This is the macro. So we import the macro, and all we do is just define essentially the structure of the event. So we say, here's the name of the event, here's the event kind. This translates to sort of like its m.room.aliases event type, and here are the fields on that event's content. And this will automatically generate all this boilerplate for us in that common case when we don't actually need to worry about validation. Jonas is asking in chat a question. Okay, so you made sure an invalid MSAS v1 content can't be constructed, but how does one actually access its contents when such an event is received and passes deserialization and validation? That may have also been overlooked, honestly. Let me see. So if we have MSAS v1 content, yeah, I think you're right that this is also missing public fields. So that is essentially just an oversight, and that's something we can maybe do today. Like, in addition to the fact that because the fields are hidden, you need to be able to you have to be able to construct it via this public constructor. We have the same thing. Like, what happens if once you deserialize it? Like, how do you actually get at the values here? So there also need to be public accessor methods to get at the internal data here without exposing the fields publicly. So yeah, good call. I didn't even notice that, and that does seem in fact pretty obvious. This is the benefit of having multiple eyes on something. Just because it type checks doesn't mean you haven't forgotten something. Okay, so that there lays out the problem. So I think what we're going to start with is so in order to do this, we're going to have to create this new result type. Interesting. Jonas says we can use the read-only crate to avoid the boilerplate of accessor methods. Though, of course, it's not such a big deal, at least here. I've never seen the read-only crate. Let's take a look at that. docs.rs, read-only. What does this do? Struct fields that can be read and written from within the same module, but from outside the module can only be read. Place read-only make on a braced struct or tuple struct. This will make all fields of the struct publicly readable according to their individual visibility specifiers, but not writable from other modules. So this essentially just generates the, I see. Does it generate accessors for you? Anyway, this is potential optimization of that. Let's look at, where's the, oh, David Tolnay, what do you know? Let's look at, where's the crate? How do you get to, yeah, David Tolnay, master of procedural macros. Here's the repository, so I'll stick this in the show notes as well, if anyone wants to check that out. David Tolnay is the same guy who built most of Serde, the serialization library that we're using, who's a total procedural macro wizard. He does a lot of really cool stuff. Okay, let's see. Man, I keep glancing over at the Twitch chat, and the stats that they show me for how many people are watching seems really off. Like, there's a bunch of people in the chat, but it says only one person is watching in the stats module. I suspect that that is not accurate. Ah, uh, read-only doesn't generate accessors, but instead another struct that the original struct derefs, but doesn't deref mute into. Oh, interesting. Yeah, that's pretty fancy stuff. I think so. This is a pretty rare case. Like I said, there's not that many events in ruma-events that actually use this pattern. Most of them actually are public, and so I don't think it's something that we're gonna really need much heavy lifting to do. It's probably worth just doing it manually rather than adding another dependency. But it's a good tool to have in the bag of tricks if we need it. So anyway, yeah, so we're going to have to, once we have our new result type, we're going to need to fix these manual implementations. So all of these events are going to need to have their manual implementations changed. And then we're also going to have to update ruma-events macros to change its implementation, or to change the generated code to work with this new API also. So I think the way we've been talking about this is, let me close this out. We're going to go to lib, and we're going to implement a result type. Where should we put this? So we've got invalid event. We've got invalid input. We've got from string error empty. I think we want to put it here maybe. So we're gonna have. This can't just be a type alias. It actually needs to be a new type. So this is going to be pub struct. I guess we'll call it event result, at least for now. And this is going to take a t. So this will be for any event. And inside it, it's going to have one field, which is a result of t or invalid event. And I think that's it. Let's see if it likes this. What's the complaint here? I don't know why it's. I think it's just being RLS being slow. And so why don't we go ahead and document this? A result. Or we'll say the result of deserializing an event may or may not be valid. If the data, let's see, how is this going to work? If the data could be deserialized, but failed validation, I'm not sure how to phrase this. When data is successfully deserialized and validated, this structure will contain the deserialized value t. When deserialization succeeds, but the event is invalid for any reason, the structure will contain an invalid event. See the documentation for invalid event for more details. This is still complaining. I think RLS is just crapping out on me. I don't know why that X is there in the gutter. So I think this is pretty much all this needs to be. And let's give this a a derive of debug. And I guess we can probably do clone also. I think that's probably fine. So that's really all it is. Type does not implement debug. What is going on here? Let me try cargo check. Oh, I should make that black so it's easier to read on the screen. What did it not like? Clone is not implemented for invalid event. Oh, really? Is that right? Hold on. Invalid event. Oh, interesting. Why is that not clone? Oh, it's probably because the error message isn't clone. Okay. So we can't do clone, we'll just do debug. That's unfortunate. That should type check. I have no idea why that X is there. It's annoying me. Whoops. Ah. Yeah, that checked. So that's result. What do we call it? Event result. And I'm wondering, I don't think we can do a blanket implementation here. Because we'll need to be able to refer to that private module. Maybe I'll just start trying to write it and see how far I get. I'm probably not going to be able to write this in a generic way. But let's see. Actually, let's find another deserialize implementation that I can copy the boilerplate from. Yeah, this guy. Ah, it was actually just below where I was. So let's try to do this. I think it's probably not going to pan out, but we'll at least get started. So this is, I never remember whether the lifetime or the type comes first. I always get it wrong. Let's see if it likes that. Unimplemented. Yeah, I always do it backwards. So frustrating. Okay. Right. Yeah, I never remember. Let's see, what is it complaining about here? Conflicting implementations of serialize for bool? Oh, right. It's not that it's T. It's event result T. Type parameter T must be used as the type parameter for some local type. Have I not done that? I'm kind of not trusting RLS right now. It seems to be kind of flaking out on me. Now, this seems like it's working. Yeah, I think for some reason RLS is like taking a really long time to run. I don't know. RLS is really flaky. I'm not super pleased with it. Like, look at this. It's been, I don't know, 60 seconds since I updated this, and it's still showing the error. Yeah, there, it just changed. That's frustrating. Okay, unused variable deserializer. Okay, so this is a valid implementation. I'm just not sure I can actually write it because I'm gonna need to refer to a path that I don't think I can actually reference via this. Because if you have a reference to if you have a reference to T, you can't actually navigate from that type to the raw module that lives next to it in the module it came from. I think that's going to be the problem we're going to run into here. And so we're probably going to have to do one implementation of deserialize per T that we're actually using in the library. In fact, that pretty much has to be the case anyway, because this can't be literally anything, because this type has to be one of our types that has this sort of fancy structure. Yeah, I could kind of hack around this with a trait maybe, but it's kind of like I don't really want to do a bunch of extra code generation like that just for like sort of my own convenience, I guess. I think I'm gonna let's just do this for one of the individual types to get started. So we were looking at and I guess this needs to be we need some way of getting at the inner result too. And I don't want this to be public. I may want like an into inner sort of method on this. I'm not exactly sure what the interface is going to be yet. So I think what I'll do for now is just pull this out. And let's go to, what was it, key verification start. Let's try doing it here. So we're going to have, where are we going to implement this? I guess it's kind of going to be in place of this from string implementation, which I don't even know if we're going to keep. Because it kind of doesn't really have a, well, we'll see. We'll leave it for now. We may find that that from string implementation is actually not even useful. So this is not going to be T. This is going to be implement event result for start event. And so how is this going to work? Basically, we need to try to deserialize the raw version. So that'll actually be the same as this. Except that we don't have... We're no longer working with JSON-specific input. So I think the way that this works is... This becomes called raw is... I think we can do it like this. Deserialize. What do I actually pass this? Oh, I guess I just specify what I want it to be. So this is going to be a raw start event. I'm not actually sure what the syntax is for this. I just run cargo check. How do I essentially like delegate to the implementation of raw? Yeah, I guess I could do it that way. So what if I just do raw start event deserialize? So this should give me, let's see, what? Oh, I need to import event result. So this comes from create event result. Oh god, what have I done? It didn't like, what does it not like here? Oh, this is supposed to be an equal sign. Yep. Expected one parameter. What parameter does start event take? Expected one parameter, but 0 were supplied. Expected result. Huh. What parameter is it expecting? What's in the raw module? Oh, I was thinking type parameter. I was like, what? I have to give it the deserializer. That's right. Thanks, Jonas. Yeah, this is very helpful to have someone else watching me where I just sit here and stumble like an idiot. Okay. So that's expected. At this point, we now basically do the same thing we were doing down here. So I think for the time being, I'm just going to move this to here. And we may want to, we'll definitely dedupe this at some point. But basically what we're doing is, so this line is going to delegate deserialization to this inner raw type that actually implements deserialize. And then if that fails, this is now the deserialization step. So it used to be that in this from string implementation, we sort of actually, we're going to have to change the definition of invalid event. I guess we can do that after we've converted all of this, because it used to be that if we go and look at the docs, invalid event actually has multiple. Oh, I guess it's not shown here, but you see how this is optional, because this can represent either a deserialization error or a validation error. And now under this new proposed API, invalid event will only ever be a validation error, because deserialization will occur at the SERDI deserialization level, and we don't need to represent that error ourselves. So right here where I was doing, right here, see, like, if deserialization fails, we return this deserialization variant. That is no longer the case. Now this question mark operator just handles that for us. And in this case, we construct, I guess that's it, because the rest of it should be the same. Oh, except that in the invalid case, we do want, let's see. Maybe we still do need to match, because if the error... Yeah, we still need to do something a little bit like this, because if deserialization succeeds but we don't validate, we still want to return... Oh, I guess it can't fail in this case. Wait, I'm confusing myself now. Because this deserialized form, when would this ever happen? So this is essentially saying if there was a deserialization error, then try to just deserialize it into a SERDI JSON value. So yeah, we actually still need to do this. We can't just throw the top level deserialization error up the stack, because we still have this sort of 2-level failure model. Yeah, this could be a problem. I think this might actually still work, because if this fails, then SERDI will... I think it should move the cursor back to where it started, and we can try to deserialize it. Yeah, I actually have no idea how this is going to work, so maybe we'll just try it. But basically, so we want to match on this rather than just throwing it away, or just question mark returning it. Oh God, why am I having so much trouble typing? So we still kind of want to do the same thing we were doing before. So either deserialization is going to succeed, in which case we just want the value, or it's going to return a serialization error. Why does that uppercasing itself automatically? That's really annoying. In which case we are going to try to deserialize it from JSON. And so here what we're going to do, let's just put it in a block for now. We're going to do let JSON equals SERDI JSON value deserialize. Oh my God, what's going on here? Deserializer. And I think this one can be a question mark. Because if that fails deserialization, then we really can't do anything with it. It's not even valid JSON. And so this really is like a hard deserialization error. So that's okay to return. But if we can deserialize it as a value, Then we want to return, similar to what we're doing below, we want to return I guess it's exactly it's just this. Ah, what did I just do? I think it's just this. And yeah. Let's see how far we got with that. I think that might be enough. Now we're still getting some errors here. Let's see what those are about. Not found in this scope. That's because I called it JSON instead of value, which I think now that we're not working with JSON input, it's okay to call the certi value JSON. Expected associated type found struct invalid event. What did I do here? Oh dear. Where is the associated type expected? Oh. Wait, what? Oh. Oh yeah, because this isn't actually an error. It's actually the error variant, so it's still an OK. Yeah, I need to wrap this in an OK, because remember, we're not deserializing event start, we're deserializing event result. So it's OK in terms of the serialization is correct, but the inner value that we have deserialized is in fact an error. Let's see if that type checks. I think that's what we want. Still doesn't like that. Expected event result found result. Oh, right, because it's not in regular result. It's got this extra level of wrapping. Oh my god, this is getting so confusing. So we've got event result, and then inside that is a result. Oh my god. This is not pretty. Okay. So now what is it complaining about? Event result has no field content. Ah, so same thing down here. This needs to be okay, event result, okay, I think. I think that's what we want now. Is that going to type check? Okay, what did I do now? Start event does not have this field. What? What's the problem? Expected start event found event result. Why did it expect a start event? Okay. Oh yeah, it's not self anymore, because this has to be start event. It's not self because self is an event result. That's just a copy paste error basically, like the context changed. Because I copied that from down here where the implementation was actually implementing on start event itself, and that's no longer the self type. The self type is now event result. Okay, use of moved value deserializer. Move occurs because deserializer has type D, which does not implement the copy trait. Consider adding a copy constraint to this for. So this is now the problem that we're running into of deserializing twice. Right. So at line 41, this permanently moves the deserializer that we're being passed to this function, and hence we no longer have ownership of it, so we can't pass it here. Oh boy. I don't think clone is going to work here because deserializers are not clone. I think we're going to have to invert this, and we're going to have to deserialize directly to a certy JSON value first. And then if that succeeds, translate from certy JSON value to our type T so that we're not running deserialization logic twice via the certy trait. I'm not even sure if that's actually possible. Let me take a look at... I think certy JSON has a method for doing that. Or let's see. Yeah, from value, I think is what we want here. So from value, we'll take a certy JSON value and give it a type T, where type T is deserialize owned. What the hell is deserialize owned? A data structure that can be deserialized without borrowing any data from the deserializer. This is primarily useful for trait bounds on functions. And deserialize owned is automatically implemented for deserialize, so it sounds like that won't be a problem. This may not be as performant as I would have wanted, but I think, like, since we're doing this sort of double deserialize either way... the downside here is that... So under this version, if this succeeded, we would never have to do this. But if we deserialize to JSON first, then we're always doing that extra step, where we're deserializing to JSON and then doing that translation. Like, that double translation layer will always happen, even in the happy case where we could have just deserialized directly, which is really unfortunate. I'm wondering if I should stop and think about that more, or whether we should just go ahead with that and not worry about the performance implications for the moment. I think in this case I can't really think that far ahead about how else we would even approach this. So I'm kind of inclined to just say, let's do it the way... Let's try to get it working before we worry about making it as fast as possible. Yeah. Okay, so I'm going to invert this, and let's move this up here. So we're going to get JSON. And at this point, we know we've deserialized. And then from there, we're going to match on certy JSON from value. And our value is that. And if it's okay, we get raw. And does this take a reference? Oh, this actually takes control of the value, so we even have to clone it. Oh god, that's so painful. Or does it give it... What does the error have in it? Maybe the error gives it back to us? What the hell is this? This doesn't actually give us the original JSON value back, which is unfortunate, because we actually want to preserve the values that we can return. Oh, this is so unfortunate, because now we've got to clone this. Because this takes the actual value, it doesn't borrow it. And I think we can just leave that as is. Let me try checking that. I think I did this right. What is it not like? Consider giving raw a type. Oh, it can't figure out what it's supposed to be. Of course. So this is a raw start event. Is it going to like that? Okay. That succeeded. You know, it occurs to me also what I should probably do is write a higher level test for this stuff to make sure that it actually works. And for that, I actually probably should have picked... a validation error. Wait, how would this even fail? Yeah, I'm not sure when this case would ever happen. Because these types both implement. What I should have found is I should have picked an event for us to work with that actually has a validation error. Maybe I'll do that first. Let's see. Let's look for inner invalid event. Yeah, I guess again they're like at this point we're not doing any sort of validation, so this could be literally any JSON, and hence this could fail. And in a sense, it's kind of sort of similar to. I know it's weird because like if we get a. I guess the detail here that's important is that this is like it's called validation because I haven't yet changed the structure of this type to indicate that it now always is a validation error. But it's kind of weird because it actually in this case kind of is a deserialization error. But I think we can I think we kind of don't really care about the distinction there. Like there'll be some sort of message, and there will be some. God, I don't know. Yeah, that's the other reason this sucks is because like if there's an actual deserialization error, like there's a field missing or something, we would have liked to return a deserialization type of error. Because this actually really is a deserialization error. And it's only down here. Yeah. You know, I think this actually this is a deserialization error. So I don't need to match on this. I just want to do this. We can get rid of all of this stuff. Because there really is no validation error in this case. If we can't convert from the certi JSON value to the raw start event, wait, is this not right? Am I missing something here? Oh, sorry, I missed a question in the chat. Content field missing or malformed will make from value fail. Yeah, so from value can certainly fail because at this point, this could be literally any JSON. As a matter of fact, this is actually really a problem because this will successfully deserialize literally any sort of JSON value. Like, we really want it to be specifically to try to treat it as an object. I don't know. I think this will maybe be okay. All right, and then nice types for all the events. Is there also some way to get the source hash map of the deserialized event? Matrix events are supposed to be extendable, so it's tricky to always force a type on library users. Yes. So the question asked is, how do you deal with an event that's not one of the ones that ruma-events knows about? And we have a facility for that. If we go back to ruma-events at the top level, there's this section about custom event types. So if we look at these traits down here, we have a trait for each of the various types. And like there's a matrix has an event, a room event, and a state event. And any given event is always implements this. In the cases where the event happened within a room, it will also implement this. And if it's implementing like the sort of state of a room, something like the room topic or something like that, rather than a transient event like a message that was sent, then it will also implement this. And if we look at our event type struct, this is the enum. This is the enum that essentially knows about all of the event types that are specified in the client server API. But you'll notice there's also a custom type here that holds a string inside of it. So these things all map to a string of like m.call.answer, m.direct, and so on. But if we try to take a value that doesn't match one of the ones we know about, then it gets inserted into this catch-all called custom. And similarly, we also have a struct for custom event, custom room event, and custom state event. And this is basically the same as all of the other events, except that the content structure is just a sort of JSON value. So if you have something that is not, if you're like extending the specification with a custom type that the spec doesn't know about, this is how you can represent it without the entire library crashing. I think that answers the question. But if I didn't explain what you were asking, then please clarify. Jonas says, no, we want to catch events with missing fields. So we need to treat the JSON from value errors as validation errors, unless I'm missing something. Sort of. Oh, I see what you're saying. So I think we want to be, so what Jonas is saying is that if we treat this as a serialization error, then this will return us to the original problem, which is that serialization errors are fatal up the entire nested structure. So if this fails serialization, then the aggregate structure that this is a part of will also fail, which is the entire thing that we're trying to avoid. So yeah, good catch. We can't actually return this as a serialization error. The only thing that's like a fatal error is if we can't represent the input as JSON. That's the only thing that we should consider a serialization error. And yes, super good catch. Thank you for that. So we do need to do this, and we do need to even though it's like it's related to serialization, we do want to preserve the original input in this case, and so we effectively treat it as sort of a validation error. And again, this is we're kind of blurring the lines of what validation means in this case, and we're kind of erring on the side of caution and saying, like, if at all possible that we can maintain the original input, we don't want to throw anything away. So if we can at least treat something as JSON, we'll always consider it a success of deserialization, and we may not be able to understand it in terms of a ruma event. But yeah. So and again, eventually this concept of like a inner invalid event validation variant is going to go away, because like there will not be anything that's not this. So this is just kind of a stopgap. I think this construct will get cleaned up a bit once we revise the error type. But I think this works for now. Let me cargo check this again, make sure I didn't make any mistakes. I think what I was saying is that I want to write a higher level test for this so that we can verify that the use case that we're after is actually being solved by what we're doing here. And for that, I would like an event that actually has some real validation logic here, because really the only validation that's happening here is just the conversion from valid JSON to our particular structure. And there are definitely some validation events or validations that are more specific than that. So let me search for validation, I guess. Oh my goodness, what is all this? Oh, that's actually not what I wanted. That's not specific enough. I'm trying to think of which of the types has a real validation in it. And how do I search for that? Because I don't remember offhand. That's frustrating. Let's see, is there one of these? I guess they all look the same when searching for this. And what kind of message do we give? Oh, maybe we want to search for message colon. Maybe one of these will. Field sender must be a string. So these are all implementations of deserialize. Ah, Oh yeah, so our start key verification start, that's the one that we are working on. This looks like a real validation error. Okay, let's go back to that. Line 152. Oh yeah, what's going on here? What am I missing? From string. Oh, it's because the validation happens in the content struct, not in the top level variant. So this is actually okay. Because remember, in order to, because the, let's see, the start event has start event content, and the content itself we also want to be able to deserialize in this way. Well, actually, maybe not. Maybe we don't care about that. Or do we? Do we want to be able to deserialize the content struct itself into this? I'm not sure that the I'm not sure that you'd ever need to deserialize just the content, not as a part of this. But it is true that in the current API we did expose it that way. So if I go to key verification start, so start event has a from string and try from, or from string implementation, and start event content also has a from string implementation. So you could extract just the content without the event surrounding it. I'm trying to think whether it makes sense for deserialize to be implemented in a similar way. I guess it doesn't really hurt, although it's a bit odd. Let's see, how would that work out? So in our from string implementation, we weren't dealing with the content here because that happens at a lower level than if we start event. Okay, so if we go down and look at from string for start event content, then this one has the actual validation. Here are some real validations. I remember when I was talking earlier about how these arrays have to have certain values in them. So this needs to be maintained on the current, on the original API. And you know, now that I look at this, it seems like this was being completely bypassed by that other API. Because if we go look at our from string implementation, oh no, it does. Wait, assert JSON. Because we're not parsing the content here. I don't think the raw, does the raw start event? Where's the raw module? I think this was a super major oversight in the previous implementation. Because look at this, all of the validation logic is in the from string implementation for start event content. But this call, that like this implementation was not being exercised by this implementation. Because we're just deserializing the raw start event directly. And then throwing this in here, and all of that stuff got skipped. So I think that might have been broken. Well, it's a good thing we never get it. Jonas says, I think it makes sense. We will then deserialize event result start event content inside the upper deserialize impl and pass the error up if one occurred. Yeah, that's what I'm sort of imagining there. Yeah, I found a bug. Indeed. So we're uncovering additional problems with the previous API that was just really showing that it's not quite suited for what it was intended to be. So it's kind of a good thing we're approaching this in a different way now. Okay, so what's going to happen here is that we need to do a similar thing. So we're going to do this sort of same thing. Let me just copy this whole thing for now. And we're going to do a deserialize for the content, which is down here. So this is going to be for start event content. This is going to be start event content. And then this part, this lower half, needs to be this stuff. So I'm going to move all of this nonsense to replace this. Hopefully I lined up the braces there. Whoops. What did I just do? Yeah. I think I lined that up right. Yep. And then this is going to be, let's see, how does this get returned in the end? Oh, it gets returned from here. So we actually don't need this thing down here because the match is exhaustive. But we do need to wrap this now. So this is now an event result, which inside it has OK. So I think we want that. And similarly, all these error variants need to be wrapped. Let's see, what does it look like again? OK event result error. So this needs to be OK event result error. OK event result. Let me do all of these first. Is that all of them? Yep. And then we need a couple more closing parens on these guys. Okay, let me just run this. Whoops. Let's see how far I got there. I'm sure I made a bunch of copy-paste mistakes. Yeah, what did I do here? Expected string found asserted JSON value. Oh, right, because we're not using asserted JSON anymore here. In this case, right. And so we're doing from value. Oh, did I already import that? Oh, I did. I don't know why. Ugh, okay. That looks... Oh. This looks right. Oh, it's down here that's a problem. From value. Uh-huh. What is it complaining about? Oh. So the JSON here is just... Oh, we don't need any of this. It's just the JSON. I think that's it. We don't need to do any sort of reparsing at that point because we've already got the original value. Okay, that worked. So that's a good sign. And is there more we care about here? Maybe that's all that's needed. So I'm thinking that we might actually just get rid of the from string implementation. I don't really see this as useful anymore. Is there any use for this at this point? Now that we're switching to this other approach? Let me leave it for the moment and think about it for a minute. The other thing I want to do is create a test for this. Oh, and we actually already have a lot of tests. So I just need to do it via the new API. And I haven't changed any of the existing implementations, so I think that cargo test, what is it? key verification start. This should run all the existing tests for this module. And I think they should still all pass because I only added stuff. I didn't delete anything. I should also switch to a branch while I'm at it in case I make some sort of completely idiotic mistakes that I want to revisit later. Let's call this event result. Okay, so that still all passes. Let's update these tests to... Interesting, I didn't know you could pass a module path to cargo test. Yeah, it's actually, I think it's like a wildcard. So if we look at cargo test help, yeah, see this test name parameter? Test name, if specified, only run tests containing this string in their names. So it's actually matching on this entire string. It's not really that it's a module path as an argument, it's just that like appears as a subset of something that's in this. So it'll filter out anything so that the test name has to contain that argument. Okay, so let's look at this and see how we're going to change this. So this is just checking the validation stuff. That's fine, that can all stay. Serialization will stay the same. Deserialization is not the same. So here we're actually going to deserialize from JSON rather than parsing like this. So we're going to implement JSON from str. Let's do that. Dot unwrap. Oh, and I guess this still needs to be... I still need to specify that it's start event content. And get rid of that parse. And let me Rust format this. I'm not sure. Whoa. What just happened? Okay, it's happy with that. And so we're going to do the same thing here. We're going to say JSON from string start event. Oh. And we can get rid of that parse. We still unwrap it. Okay, let's see if that works. Oh, right, I can't deserialize that directly. I have to use, that's the whole point of this, is I have to do the result. So what we want is event result of this. And then also, importantly, I need to now give some way of extracting the inner result from, if we go back to lib, I need some way to actually get at this inner result so that I can deal with the value. I'm kind of wondering if I just want to make this a public field. Is there any downside to just making this a public field? I guess the only downside of this is I don't really love public APIs that use tuple structs, because I find like having .0 and .1 rather than field names is not particularly nice to work with, and I tend to only use those in internal APIs where I know what it is and I don't have to worry about it. Basically what I'm wondering is whether to make the field public or whether I want to do like a conversion or something. Yeah, so Jonas is saying another possibility would be to make event result in enum, would make matching easier, and we could provide a from impl for getting a standard result. Yeah, that's kind of what I'm thinking now too. Is like just make it essentially a copy of the result enum, and then we can just do a from impl, and so someone can just call .into on it to convert it into an actual result, rather than like extracting out the result that's contained within. I guess that's also a safer API in case we have a reason to change the internals of event result. It'll also make these constructs a little bit easier to read, where we've got like event result. Let's see, where was that? Event result. Yeah, like this stuff. This might be a little bit easier to read. Well, I guess not that different. Yeah, I'm kind of inclined to do the enum approach. Oh, hey Chris. Chris is also voting for the enum version. Yeah, I think that seems like a pretty nice API. So let's do that. Let's say that this is an enum, and we've got either OK, which gives us a T, or error, which gives us an invalid event. And so this is T deserialized and validated successfully. And this is T deserialized but was invalid. Invalid event contains the original input. I think this is what we want, and then we can just give a from implementation. So impl t from event result t for result, and I guess this will be, oh yeah, result t invalid event, right? Did I type that right? Why do I feel like I... Oh, that seems right. So then this has a from, and event result is event result t, and this returns self. And so we're going to match event result, and if we've got an event result OK with a T, then we're going to return OKT. And if we're going to, if we've got an error, then we're going to return an error with the invalid event. And I think that's all we need. That seems pretty nice. So then down here, let's see. So we get back, yeah, where were the tests? 601. So down here we've got a test. We need to convert that into a result. Is that right? Yeah, we convert that into a result. Wait a minute. Into a result, and then unwrap the result. I think that's the right API. Into unwrap. Let's see if I did that right. Oh boy. Oh right, because I've now changed the structure of this. So I need to update all of this code. So this is now event result error. And we can get rid of one of these guys. Yeah, the problem with creating our own result type is just the reason that having a new type is annoying in general is like there's a reason that result is generic is that it provides you with all of this nice stuff that you want to be there. And when we create our own type, we sort of have this tendency to want to start moving commonly used methods from from the real standard library result into our version, and then it just becomes this nightmare of like ever more needing. Oh God, what have I done? 601. Not found in this scope. Oh, I didn't import it? I guess not. So here I want, what is it called? Event result. Let's Rust format that. Okay. Yeah, it just sucks. Like, I wish there was like an either a way to get around the coherence issue, or like a like there's been some talk about having like a delegation feature where you're essentially saying like, I'm creating a new type, but it's really this other type under the hood. So just like anything this other type implements, give me a version of that on my type. Oh my God, just cracked my chair. Holy crap. Good Lord. The the handle of my the right armrest of my chair just cracked. Good Lord. I guess I've had this chair for a long time. It's getting pretty old. Or maybe I'm just getting too heavy. Probably a little of both. Okay. Or something else cracked, because now the chair's like leaning way, way back. Oh my God. Yikes. Let me try to sit up a little more. Let's see. Yeah. I'm actually going to take a quick break to maybe switch to a different chair and stretch. So let me switch to my BRB screen. I will be back in a minute or two. Okay, I'm back. Yeah, that was kind of hilarious. I'm kind of glad I caught that on a recording actually, because it's pretty funny. My chair cracked. I don't seem to have another chair that would like be a good fit here, and I don't want to like spend a bunch of time on stream trying to reorganize my desk setup. So I'm just going to deal with it till the end of this stream and then figure out something else to do later. Let's see, where did we leave off? So we've got, oh, interesting. We've got another coherence issue. Type parameter t must be used as a type parameter for some local type. So this is the orphan rule that we were talking about earlier. I can't implement this trait generically because the from trait is not from our crate and the result trait is not from our crate. And so in order for this to be generic, or for us to implement this, all of the generic parameters must be bounded by a trait that comes from our crate, which is not the case. So I think what that means is that we can't have an into implementation. It's going to have to be an inherent method that's just called into. Man, that's unfortunate. Yeah, maybe into would work. I think it's pretty non-standard to have a direct implementation of into. It's almost always... I think it's going to end up with the same problem because you can't have the t in the implementation, in the self type. Because, like, if you think about the reason it's conflicting here is because of the orphan rules, not because of the other coherence rules. Like, we don't own from and we don't own result, so we can't make it generic. This is why you have you find inherent methods on types out in libraries out in the ecosystem that are called like into inner and stuff like that are inherent types. See, Jonas says, I think it works because the type you implement it for is a local type, even though it has an unbound type parameter. Oh, yeah, you're right. Well, is that right? Into, yeah, maybe that's true. Let's give that a try. So if we say impl t into result t invalid event for event result t, maybe this will work. So we've got into, so this gives us an event result. And wait a minute, did I write that backwards? No, that's right. This gives us a result t invalid event. And then this is the same. Let's see if that works. I think it's pretty rare that you implement into directly, because usually you get the has a self. Oh, right, because this is a... Oh, right, it's just self. I don't have to... It doesn't actually have a parameter. So this is just self. Yeah, usually you get your into implementations from the blanket implementation in the standard library that says everything that it implements from also gets an into with the, you know, the conversion reversed. But I guess in this case, all we care about is into, so it kind of works in this case. Cannot infer type for t, that's kind of expected because we are not saying, let's see, where is it? Where can it not infer the type for t? It can't infer the type for t at which point? At this point? Maybe it's because of this? Result start event content invalid event. Is that what it can infer? Interesting that it didn't complain about this one. What did I do wrong? 605. Whoops. 605. Oh, I'm missing one closing. Yeah, it probably just didn't get far enough, and I'll now get an error message about the other one. Cannot find invalid event in this scope. Oh my god. Give me a break. Invalid event. Let's format. Wrong number of type arguments. Why is that? .606. Ugh. What am I missing here? Jonas says, because into the function doesn't have a type parameter. What is the significance of that? Meaning it can't tell what it's converting from? Tell you what, let's do this step by step so it's more clear what each of these is. So this is, I guess this is like a deserialization result. And then this is event result, ser result. And then this is regular result. Oh wait, I need to move this stuff out to up here. And then let actual is result dot what? Result dot unwrap. And so we want to assert that the actual is equal to the expected. Right? Let's see if how far we got there. So it is on this step about that into call. Oh, I see what you're saying. Type annotation on a result. Because I'm putting the turbofish on the into call, and the function itself doesn't take a type. That's what Jonas is saying. So change the turbofish to a type annotation on result. Yeah, maybe I just want to do this. Or yeah, basically I want to move this nonsense over here. Is that going to be enough for it to figure it out? Oh god. What have I done now? No? Didn't like that? What is it complaining about? Expecting double colon. Oh. Right. Don't actually need those outer angle braces. Okay. Okay, so same thing on the next one. So let's see, how do I write this if I'm not putting it in intermediate variables? If I wanted to chain this, how do I chain it? Given that the type parameters are not on the function. Does that require type description, or is there just some syntax that I'm not thinking of? So if I wanted to go back to how it was before. Let's go back. So here, like, where do I put this assertion when I don't have a variable to assign it to? I think maybe I actually have no idea how to do that. Maybe an as result start event content. Let's try. I'm not sure if this will work. I don't think it will, but it's worth a try. I think it's going to choke on the syntax here. No rules expected this token in a macro call. Yeah, it doesn't like that. I have no idea how to do this syntax. Wow, that's really nasty. So essentially I have to use the disambiguation syntax Jonas is suggesting. So rather than do this stuff, I would have to do into and then call this. That's really, really, really nasty. I don't like that. What I'm going to do instead is I'm going to not implement the standard library into trait, and I'm just going to give this an inherent method, so it doesn't need to use trait resolution to figure out what I'm trying to do. I think this is a shortcoming of Rust, the fact that there isn't a nice way to do this. But I think for the purposes of making an API that's actually nice to use, I think it's more important to use a less than ideal, or a sort of a less pure implementation of making this work, so that the code that you write at the call site is less painful. So what I'm going to do here is I'm just going to do impl t event result t. Don't remove the impl. Why not? I mean, I guess I can leave it and we just won't use it. You can have both an inherent method and a trait implementation. Yeah, but why? Like, we're not going to use it. Like, when we can always add this back later if there's a use for it. I think it just doesn't really add much at this point. Well, in any case, we're going to do. I don't know if I want to call it into, because then it's going to be like. It's going to be the same nonsense as before. Result t invalid event. And we're going to have exactly the same thing here. I'm really questioning whether there's a value of having this here, especially if they have the same name. Yeah, I don't think there's a use case for this. And because it's additive, we can always add it later if we find that there actually is a use for it. I'm inclined to just stay conservative for now. Method. Oh yeah, so this needs to be a public method. Convert event result t into the equivalent standard result t invalid event. I think that's all we want. So let's go back. Where was it? Like around 601 or so. And so here we can get rid of this because this into call is now coming from the inherent implementation, and it doesn't have to disambiguate because it's no longer a trait. Let's try this again. So far so good. I think it would have shit itself by now if it wasn't going to work. Okay, that passed. So we seem to be doing what we want. Now, to make sure that this is... So the happy case it seems to be working, that when we're deserializing content that we know is correct, it will work. And so what we want to do... What we want to do now is test the error cases. So here we've got this... We've got straight up invalid JSON. So I think here we're going to do the same thing, where we're going to asserty JSON from string, and this is going to be as a start event content. And we're going to get rid of this parse call. We expect it to be an error. We unwrap that expected error, and we expect serialization to fail. And in this case, the error will actually be a asserty JSON error. So I think I actually want to assert that this is a asserty JSON error. Is that right? Like, how do I distinguish that this is... What does asserty JSON error have on it? So if we call if we call from string and we get a result back, what is the result type? It's this type of error. Ah, interesting. I'm actually not sure. Ah, there's an unwrap error method on result. I didn't know that. Or perhaps I did, it just didn't occur to me to use it here. Maybe I'll just call one of these methods on this type to make sure that it's actually a asserty JSON error instead. So let's get rid of this, and we can change this to apparently unwrap error. That's nice. And so here we care about error comes from, wait. Ensure that the error comes from asserty JSON and not ruma-events. So here, what do we want to know about the error? That it was... I guess this is a syntax error. So we'll say assert error... Whoops. Assert error is syntax. Let's try that. Okay, didn't like that. Serialize is not satisfied. Yeah, I guess he's right. I don't have to. I think it's just that it's not as clear unless you're looking at the actual API of this. The fact that it's checking that. Maybe I can just combine it into this. Or actually, what I really want is this. Assert is error. Right? I think I can do that. And then what I can say, ensure that invalid JSON, what the hell? Ensure that invalid JSON creates a asserty JSON error and not a ruma event, and not an invalid error or invalid event. And then we can just get rid of this extra thing. Because yeah, you're right, we know that this, if this top level from string error is an error, then there's nothing else. What was it complaining about, that previous error message? deserialize is not implemented. Oh, right, because this needs to be an event result. That's the entire point of this. You cannot deserialize the event itself. You have to wrap it in this our special result type. Okay, that looks good too. And then here we have the cases that are about deserializing specific stuff. So these are non-JSON deserialization errors. These are the actual sort of validation errors. So what we can do here is assert a JSON from string, and we'll get rid of this. We still need to put this in, which is kind of annoying. So this is a event result of start event content, and we can get rid of the parse implementation, and this can be this is actually going to be okay. So it's actually just unwrap here. Because this actually returns success, but it's one of our, it's the error variant of our result, event result. So we actually want maybe into unwrap error. I think that's what we want. That'll actually give us our innermost error. If I can type this method chain correctly. Yep. And then maybe that's enough. Let's see how far we get with that. Okay, that still works. So deserialization structure mismatch still works under the new API. I think this is going to be similar. This is pretty much the exact same thing, but with a non-structural issue. This is the one that's actually checking that the field contains one of the values that it's required to contain. So this is a real sort of logical validation error that we want. So let me do this again. Let me actually move this line, because that's already got a little bit of the turbo fish that I want. So this is going to be assert JSON from string, and this is an event result of start event content, and it's, whoops, and we're calling that on it, followed by we expect that, we into this, and then we unwrap the error. So this is all the same as before. And that should be the same also. Does it not like this? What's it complaining about? That looks right. I think it's just RLS being slow. So if this works, then we are really in good shape. Excellent. So I think now we know that the validation event validations are working correctly as well. And we want pretty much the same thing for this next one. So here we go yet again. Let me just, now I can just copy this line. Whoops, what did I just do? Yeah. So we'll copy that line. We'll move this. Ugh. If I could type correctly. We'll replace this with this. And these three will come down with us as well. And the rest of it stayed the same. And I guess we can do the other ones while we're at it, so we don't have to keep running the tests over and over. So we'll put this in here. Move that guy to the right. Move this guy to the left. Move these guys with us. And is that the last one? No, there's one more. Let me actually copy these now. Get rid of this. That guy is going to turn into this. This guy is going to go to the right. this guy. Whoop. 675. This guy is going to come down with us here. And I think that's all. Let's see if all of that works. Okay, it all worked. Let's update our documentation just to see kind of what we built here. So this may be technically a little less performant than the previous iteration of this, but it actually works, which is, I think, like there's no point in something that performs well but like can't even be used. It kind of defeats the purpose. Okay, cool. So we do not have an implementation of serialize for start, or deserialize. We don't have a deserialize implementation for this. Actually, where does that... Let's see. We defined this as... Oh, you know, so I guess the implementation for this will appear... Let me refresh this. We've now got our new event result. There we go. So all of the deserialization... This is a little unfortunate that... because we're not implementing deserialize directly on these two types, it's not super apparent from looking at their documentation how you deserialize them. So this is a case where the generated documentation is a little bit unintuitive because of where this implementation actually exists. But I think if we just explain the general pattern in the crate level documentation, it will be clear enough how to go about this. And also that really the main consumers of this library are our own library, so we know how to use it. I mean, that's not a great justification, because the whole point of having this be a separate library is that other people can build on it. So we still need to make sure that it's explained appropriately. Okay, cool. So the next part of... I think I'm going to stop the stream here for today, just because it's already been a couple of hours and I've got some other things I need to do this afternoon. But we made some really good progress. I think we kind of proved out that this API is going to work. Although I guess we technically didn't, because we still haven't tested a version of this where we are embedding the event in a larger structure, which is really the use case that I failed to recognize when designing the previous API. So if we look at these tests that I have here, we're still always deserializing like the event that we care about separately, rather than like the type of structure that's actually going to come from the Matrix API. So I kind of do want to test like that eventually, but I think we're on the right track here. I don't think yeah, I'm confident that this is going to do what we want, as Jonas has just said. So I think this is probably a good place to stop. What I'm going to do here is just review... actually, let me do... I guess we're done with this file. What are the things that I always do on this? So I'm going to do a cargo audit, which doesn't really matter for the purpose of this. We're good. Cargo format. Let's do cargo clippy on everything we've done today to make sure we are not introducing any sort of code quality issues that can be easily detected. I think we'll be fine, but just to check. We've already run the tests, so we know it builds, we know it passes all of our expectations. So here I'm just checking for code quality stuff, and that's good. So we're going to say, I think I'll actually separate this into 2 commits. Let's take a look at source lib. Yeah, so git add source lib, and this is add event result type for fallible deserialization. Okay. And then we want to, this is impl deserialize for event result of start. start content, and this is kind of, we'll deserialize for m.key.verification.start. Let's just refer to it that way, since it's more clear what that is. Okay, and then I'm going to push this up to a new branch so everyone can go and look at that code if they would like. And that you can find here. Oh, that's giving me a pull request. That's not what I want. I just want to, well, you know where ruma-events can be found. It's on the ruma-events repository. You can check out my event result branch that I just pushed up. It's got those 2 commits. If you're watching this as a recording far into the future, obviously this will probably long since have been merged into master, but for those following along right now, that will be good. Let's see. Jonas says, can the from string implementations for those 2 types now be removed? They were probably only used in those tests, right? Yes, I think probably the from string and try from implementations are not going to be useful after we finish this API, because you're never going to be converting directly from a string of JSON directly to the event type, I think. I like, the new API does not really remove the ability to do anything that you could do with the previous API. Like, you just basically change the name of the type that's being deserialized, and if all you want is that inner part, you just need to unwrap an extra layer. So I'm pretty sure that the from string and try from implementations will be removed as part of this revision. I'm leaving them for now, and I'll just save that as a separate step to remove them later, and give myself, a few days to think if there's any reason why we would need to keep them. I don't think there is, so I think they're almost definitely going to go. Okay, well, that wraps up for the stream for today. I'll probably be, I'm not sure, I don't know. Some of this is kind of boilerplatey, so I'm not sure I'm going to stream all of it. I think maybe the other thing that would be worth streaming would be updating the ruma-events macros library to use this new API for all of the ones that are auto-generated. I think that's probably worth doing on stream, because that's like essentially what I did today. I'm going to have to do for like those other events that that manually implement these traits. And I don't think that that's particularly interesting to watch, since it's effectively the exact same thing I just did, but for a different type. But I think the procedural macro part of it will be interesting to watch, because then we're dealing with it's still effectively doing the same thing, but we're working with this extra layer of indirection that's introduced by the code generation in the macro, and I think that's procedural macros are not a particularly sort of newbie friendly thing for people who are just learning Rust. So I think there's probably a lot of value in having some more recording and example of like how you actually work with them that people can refer to. So I'll probably do that tomorrow, or possibly Wednesday, but certainly later this week sometime. That'll be the next stream. So thank you very much for anyone who's watching this live, and for anyone who gave some feedback on what I was doing. That helped a lot to have you all with me kind of pointing out the obvious mistakes. And obviously Jonas especially has been very vocal and following along and helping me see the walls that I'm walking into it at every step of the way. So yeah, this whole streaming thing seems to be working out pretty well in terms of my goal of kind of getting from it the benefits that you get from pair programming in general, which is just that other set of eyes, and things that you all know that I don't, I learn from you, and things that I know that you don't, you learn from me, and as a result, we all get better over time. So thanks again. This recording of this stream will be uploaded to the YouTube channel, so you can follow me on Twitter. At twitter.com/JimmyQuadra. I will tweet the link to the recording when it gets processed by YouTube, which usually takes a couple of hours. And if you have any reason to refer to it later, you can always watch it again. So thanks very much, and I'll see you next time. Bye, everyone.